Hi friends, welcome to example 1 for the Unit 4A notes. Here we're going to be drawing an acute isosceles triangle. Sorry for the errors here. And then it says we want to draw the described triangle, and it says mark the diagram accordingly. So the big thing is perfection is not something that we really look for. Having the diagram marked is really what's key in situations like this. However, imagine you were trying to do this for a job. You're marking up a diagram. Maybe you're marking up a diagram for a building. Maybe you're marking up a diagram of, a person. You want to be as accurate as possible in those circumstances. Otherwise, the consequences could be pretty bad. So this is an isosceles triangle. So we want the isosceles part. So we want two of these measures, two of these segments to be the same. So I'm making it very similar to what we did earlier with this. So you will see here, I'm going to go like this, and then like this. So again, the important part to note is how I mark this. So I need to mark that these two sides are congruent. You don't need to mark something to show that an angle is acute. Remember, we only show right angles that with the symbol here. So this is sufficient for example 1. The next one, draw an obtuse isosceles triangle. So this is where I need two of the side lengths to be the same, but I need it to be an obtuse angle. So that means I'm going to fan out pretty wide here in the beginning. So I'm going to do, let's go to here. So here, and then here. Now, as long as I connect this, I know it's obtuse because the angle's obtuse. Now, there's not a lot of room inside this triangle compared to some of the other ones. There we go. But again, it's okay. You see the congruency marks? This triangle is contained in this box, so I just used one congruency mark for each. Does not mean the sides are the same length as this one here. This is also contained in its own box. So be careful with things like that as you're going through and doing your problems. These boxes are self-contained. This says draw an obtuse scalene triangle. So in this case, I need to make it so that none of the lengths are the same. And it's scalene and obtuse. So I'll do something like this. Let's go like that. Let's go like this. So I'm just beyond that. And then this is really far beyond it. There we go. So none of the side lengths are the same, and it's obtuse, meaning that this angle right here is greater than 90 degrees. Page 2 now goes over example 2 here. For this one, it says complete the sentence with the words always, sometimes, or never. What I would do right now is go ahead and pause the video, try these, filling out with your pencil, fill out what you think to be true. So always, sometimes, never. Pause the video, see what you get, and we'll talk about it. Going through these, you have to think about it has to be something, if you say it's always true, then it has to be true 100% of the time. If it's sometimes true, that means it can or can't, and then never means it's never true. There's never a situation. So if I talk about this, an isosceles triangle is sometimes a right triangle. It doesn't have to be, and there is situations where right triangles are not isosceles. An obtuse triangle will never be a right triangle. And the reason is because we only have so many degree measurements to work with. And so you can't have something that's greater than 90 degrees also with something that's 90 degrees with another angle measurement to come up to 180. It just doesn't work. A right triangle is never an equilateral triangle. You can never have a right triangle also be equilateral because equilateral triangles are also equiangular and they have to be 60 degrees. A right triangle is sometimes an isosceles triangle. This is a rewording of the first one. If you said the first one was always, then you should have said this one is always true, because always means that it works both directions. So notice that that's sometimes. Example 3, now we're classifying it by its sides and by its angles. This one for A gave me that it was 120 degrees, which is good to know. Again, we could check saying that it's greater than 90, which is the important part, because that means that it's an obtuse. And then we also note here that it has these 3 measurements that are all different, so that means it's scalene. So this is an obtuse scalene triangle. For the part B, we have noting that it is this angle measurement, it's a right angle, so that means it's a right triangle. And then it said that 2 of them were different, so what about the third one? Well, if it doesn't have a marking there, we can't assume that it is. This is actually a situation where if the information of congruency is not given, you can't assume. So this is a right scalene triangle. And then for this last one, this actually gives us both of these angles are 78 degrees, and that these 2 are congruent. So this is an acute isosceles triangle. I spell isosceles wrong. I always have to double check that. I-S-O-S-C-E-L-E-S. Isosceles. And again, we can find it out that this angle measurement's not 78 degrees by adding these 2 up and then subtracting that number from 180 to get that last angle measurement. For this one, I'm going to save example 4 for the next video, so I will see you there. Have a great day.